Okay, and we're back. So where are we here? Okay, let's build the thing. Okay, what does it do? Oh, it rotates. That's for the rotation one. Okay, now I remember. Okay, what's the code? Okay, we do rotation. Now we do convolution is too complicated, so let's do scaling, I think. Okay, why are we back? Type index map. Okay, rotation, scaling. Okay, copy and paste. Scale. Okay, I don't think we need center. Scale is just take one image, take the source shape, and then stretch it to fit the result shape, whatever the size is. Okay, this is the part that's difficult. Okay, I need to remember how to do this here. I'm looking for the source. There's something that shows how to do this. Okay, let's see if I can figure it out. Okay. Okay, it's I times. Okay, we need to take the ratio of the source to the result, and then multiply it by I. If one's bigger, then the value will be slightly less than 1. If it's smaller, then it's slightly more than 1. Okay. We just have to get everything in the right order. Double source dot shape width divided by result dot shape width. No, result dot shape width. Just have to be sure to get everything in the right order, because getting it wrong in the wrong order will mess everything up. Okay, long XYZ. Okay, did I get everything right here? I hope so. Okay. Okay, we divide to get the ratio somewhere between, somewhere close to 1, slightly more than 1 or slightly less than 1, depending on what the size of each shape is. Okay, IJK, IJ. Let's do everything for J and K. Oh no, J and K here. Source shape width, shape height. Okay, shape depth. Okay, shape depth, shape height, and that's it. Assuming we got it right, that should be it. We take the ratio and then multiply it by the counter, by the x coordinate, xyz coordinate. And oh, we don't need this here. Okay, source and result. Scale just requires source and result. That should be easy. Okay, now to use it. It should not be as simple as type create shape. Okay, let's see how do we use it here. Create scale. To get scale index, we don't need the R. Okay, shape. Now we need a second shape. Okay, shape 2. Okay, shape 2 assign. Type shape assign. Let's see. Let's say 100. No, shape 2. 100. 1. Okay, shape 2 assign. Shape 2. Okay. One thing about the index map thing is that the two shapes don't have to be to fit the image exactly. They can just be somewhere within it, and the function will take care of to make sure that everything is within bounds. So it really doesn't matter that the shapes are not the same size. Okay, so shape scale, we copy into an image, and that should be it. We build solution, unless I made a mistake. So, oh, we made a mistake. Okay, it's wrong. Okay, I have to figure out what I did wrong here. Okay, first of all, I made several mistakes here. First, I cannot just set the shape to some arbitrary value. I have to set it to the same size as the image 1. Image 1 create 100 by 100. So it's just a smaller image. And then second, I have to set the shape to exactly the same size as the image. Otherwise, everything is going is just going not going to work. 1 image width, image 1 dot image height. I can shrink it and then grow it back up, but ultimately it has to be the same shape. Image 1 create, shape assign, image 1. Okay, I just move everything down just so it's all clear. Shape assign image 1. Okay, sequence create, shape assign image 0. Okay, shape 2, shape assign image 1. And oh, and also result. I have to move the shape 2 over here. It's the result. So result first, source second. Okay, let's see if it works now. Rebuild. Oh, there it is. It works, but it's in the wrong position. It's in the wrong position. Okay, but it works. Let me just fix that here. This right here we have to fix. The position of the images have to correspond to image 0, the size of image 0. Okay, location 1. Okay, it works. It's just in the wrong place. Okay, come on, let's work. Oh, it works. It scales the image, make it smaller, make it bigger. But the size of the shape has to be the actual shape of the image. You can't just have a smaller shape inside another image. Actually, you could, but it would be rather complicated to implement. Okay, scaling works. And now for convolution. Okay, the big one. Okay, index map convolution. Create convolution 2D. Because of the way convolution work, we're just going to do convolution 2D instead of a full 3D convolution. If we try to do 2D convolution, then we have to do neural network stuff and multiple filters, and that's just too complicated. Okay, convolution 2D. Convolution 2D. Okay, source, result, and filter. Shape of the filter. Got source, result, and filter. And filter. Not filter. Okay. What do we need? Convolution 2D. We need X, Y, Z, XC, YC, and X something. Okay. What do we need? Oh, filter. Filter. Oh wait, we don't need filter. Oh, we don't need to do the shape to filter. Filter width and filter height. It will set everything by itself. Unsigned long. Filter width. Let's push that side. Filter height. Not unsigned long. Filter height. Okay. Filter width, filter height. What am I doing? Okay. We need to filter. Double filter width. Is it double? No, it's filter width. Width divided by 2. Filter height. Height divided by 2. It's XC. Oh, it's long. Okay, filter height divided by 2. We don't X sign. Nope. For I equals, we have to do it in 2D, just like with the rotation, because otherwise just get way too complicated. Okay, X center. XD. Oh, actually we do need XD. xt and xc, same as always. Oh, xc, x center, yc, y center. Okay, xt equal what? I minus xc. Okay, so we need the center of the filter, the center point of the filter. Okay, so we need a loop for, oh, we have an x, y. Oh, really? For x equals 0, x is less than filter width. Oh, we have to do y first. Oh, this is important. We have to do y first. Filter height. We have to do it in a specific order. Y plus plus. Okay, next, for x equals 0, x less than filter width. No wait, filter width, x plus plus. Okay. We don't need this one here. Okay, source index. Okay, we have to do it inside a thing. Source index dot. Okay, shape get index x xs x center xt plus x yt plus y. Okay, how does this work here? In convolution, we are placing a filter over a specific pixel, which is the result index, or is that the source index, and then calculating all we set the, and then we move backward by a certain amount, and then we calculate the values of all the pixels around it. This is how we do the convolution thing. You should know how the convolution works. Okay, so we add value. Add value inside. Okay, so we add value inside here. Okay, this part is actually very simple. So for every pixel in the result index, we place the filter at the center. We place the filter over that pixel, so that the center of the filter is on the pixel. And for every pixel in the filter, we calculate the value with the value of that pixel over of the pixel that it overlaps, or which pixel it overlaps, and then we add the value to the index, to the list of indices. To do the convolution, we simply have to average all the pixels. Okay, so yeah, now we have to go in the image. Okay, now we're inside image, and we take copy and just copy it. Okay, now we have to convert it into a convolution. Okay, convolution, index map convolution. What do we need to know? Okay, a source, image, and filter. Double. It's a list of double values. Double filter. Okay, we also need to know the width and height of the filter. Unsigned long filter width. Unsigned long filter height. Okay, that's just to be clear here. Okay, now we have this filter. We need to make sure that everything is correct. Okay, if filter. Okay, filter length. Oh, wait a minute. Length. If filter width times filter height, okay, not equals index map index map dot index height index height, then we have a problem and we turn 0. and return 0. Okay, we need to make sure that the size of the filter is the same as the height of the index map. If it isn't, then we have a problem. Okay, now everything else should be mostly the same, except right here. Times we need to multiply each pixel by the filter value. Okay, by the way, doing image convolution is not the same as doing neural network convolution. There's a slight difference, but mostly it's the same thing. Well, there's more than a slight difference, but mostly it should be the same thing. Filter.j. We just multiply everything by the filter, by the value of the filter, and then down here, counter plus equals. We have to divide by the total value of the filter, because otherwise the image is just gonna get brighter or darker. There's a video on Computer File that explains exactly how to do this. Well, not exactly, but if you want to know how it works, just look up image convolution in Computer File. That's the best way. That's the best way to learn how to do this one. Okay, counter plus equal filter.j. Same thing. We just add up the filter, the value of the filter, and the counter, and everything else is just the same. We just divide by counter. Because we're using double here, everything has to be set to double values. Otherwise, we lose precision. Okay, double. Okay, double values. Okay, divide equal doesn't really work here. R equals R divided by counter. Oh, what am I doing? G. How exactly did that work before? Oh my god. Oh, that was a mistake. That was a big mistake right here. It's R, G, and B. Fortunately, the image only has one layer, so the division never happened. If counter not equals 0, has to be because everything's floating point this time, so we have to set it, so you have to check exactly 0. R, G divided by counter, B divided by counter. Everything else is the same. Unsigned SHA max. So hopefully it should work. Hey, actually it's not that different at all. Okay, everything is correct, I think. Okay, now let's go back and see if we can do the division. Okay, another place to get code for convolution is Wikipedia. Okay, you can see all this stuff here that shows how to do the convolution and the pixel. Add result to accumulator, set output image to accumulator. So this is the place where we got most of it. Okay, this is the code. We have. It doesn't say that we're supposed to divide, but I know from experience that we need to divide. But what I need here is the matrices here. So let's just, yeah. Okay, it's gonna be tedious. Let's just pause and then I'm gonna copy all this stuff. Okay, index map create convolution to the shape. The shape of the filter is 3 by 3. Okay, so now we need to index map convolution. Convolution. Should it be convolution 2D? Yeah, index map. No, we need to define the filter. Okay, filter. And we need to define a filter. Our filter is edge, Gaussian blur, or sharpen. Edge 1. Edge 2. 3 by 3. Not 3 by 3. Not 3, comma. Edge 2. Wait a minute. What am I doing? Okay, we need to define a pointer for the filter. Double filter equals. What does the filter equal? And double. Very double. Double. What am I doing? Double pointer. Edge 2. Why edge 2? I don't know. It's as good as any. Okay, filter double edge 2. Did I miss something here? I think I did. Filter double. Double filter. Why doesn't it work? Double cannot initialize entity of type double. Oh, that just doesn't work at all. Okay, now we have the filter initialized. Okay, we need to define clip, map convolution, shape, and filter. Filter 3x3 index map. Okay, that should do it. I hope. I'm not even sure. Okay, unless we're missing something. Okay, now. Okay, put this outside. Because I don't want to have to create and destroy every single time. That's just unnecessary. Index map create scale. Type filter destroy. Alright, this is getting weird. We're getting really cluttered here. Okay, let's save everything and build. And we build. Nope. No. Okay, now let's save everything and we build again. I just hope it works this time. Oh, it doesn't work. Of course. Of course, I forgot to resize the image. That's what happens when you keep using the same code. Okay, resize the image and then try again. Oh, there it is. And it works. Got emboss. Okay, let's try the other ones. Sharpen. Okay, now we change from emboss to sharpen and then we build. And it works. Okay, as you can see, the images, it looks really bad here. So the problem that it goes over the limit. The pixels can only go from 0 to 55, but because of the way the multiplication, the convolution operation works, it kind of puts it outside that range. Because of the divisions, of the additions and divisions, it puts it outside that range. So we need a function called image max out. Okay, double image max out. I don't remember why I call it max out, but it simply limits the value of the pixel to something that's valid. Okay, a. Now, if a is less than 0, return 0. If a is more than 255, return 255. Okay, return a. Return a. Now you have to copy max out. Okay, copy max out to some over here, down here, yeah, right here. Image max out R. Okay, image max out G and B. We need to round everything to 55. Okay, now it should work. I hope. Okay, build, rebuild. Oh, stop debugging. Oh, it's still debugging. What am I doing? Okay, rebuild, build, rebuild. It's causing problems. Is it rebuilding? Oh, it's done. It's not even said. Oh, that's better. Okay, so it didn't change it by a lot. That's what I don't like about those filters. It doesn't change it by a lot. Okay, let's see. So we need several filters. Okay, we got sharpen, Gaussian blur. Let's see, Gaussian blur, what does it do? Come on, come on. It's kind of blurry, but not a lot. That's what I don't like about these things. There's a way to fix that. Emboss. Emboss should be more visible. Okay. Boss. Oh, emboss. It does a little more. But none of that matters really. All we know is that a convolution works. Type image convolution works. Okay, now that we have this, we have scaling, we have convolution. That's not the only kind of convolution. There are other kinds of convolution, and if we need to do it backwards, we have to do transpose convolution, which is for backpropagation. So we need to learn to do that. But there is also another kind of convolution called at-rule convolution that makes everything more blurry. So we're gonna do that next time. So that's done now.